Okay, so that's what we're going to be talking about today, are the how to solve systems of equations. But we're going to do a little bit more today than just talk about how to do them. I want you to visualize what these equations really are when it comes to graphs. Okay? So I don't believe we need this. Okay, so the first thing I want to talk about, what we're going to be talking about today, are systems of linear equations. And what is a system? It's a what? A system is just what? More than one equation. So you might have 2 equations or 3 equations. And usually, if you're solving a system, those equations are representing something from a graph. So you'll have multiple variables. And if I say linear, what do you think linear means? Line. So we're just talking about how do you solve, basically find out where lines intersect. Now, think about this for a second. If I have 2 lines, what are the possibilities if I graph them in terms of where they intersect? They could, what? Give me some options. 2 lines on a coordinate plane. They could cross each other. Okay, so they could intersect at one point. Something like that. All right, we're going to talk about how to solve lines. A lot of different ways we can solve lines and get an actual solution. But what also could happen?
Parallel.
So here you get one solution. If they're parallel, and how many solutions are you going to have?
None.
None.
Oh.
So this would be an example where there is no solution. Null set or no solution. Now what if they are not parallel and not intersecting, but what if they are, is there another option? The same line, maybe written in a different form. So if it's right, if one line is right on top of the other, and this is where people tend to make mistakes in their solutions, but what would you write as your actual answer? Great, I never hear that correct on the first. Most people go infinity or all reals. Now here's where they're off on that. He said the actual line would be the solution. That's fantastic. And here's the formal way to write that. If you mean the line itself is the actual solution, then what you're really saying mathematically is any point xy, this is how you write it mathematically, that is, or such that, it exists on the actual line itself. And you would just write the equation of the line down in whatever form you want. So basically, any point on this line would be your solution set. But you know why it's bad to say all reals? Because if you say all reals, what are you really saying? It could be any point. And is that point on there? Is that point on there? Are all these points on there?
No.
If you say infinitely many, why is that bad? It's better than all reals. Why is it bad? What about like this? Hey, what foods do you like? Lots of them. I mean, be more specific. Tons of food I like. You still haven't even given me one thing, right? So if I say, what are the solutions? You go, man, there's tons of them. You really haven't even told me the first one, right? I'm still as clueless as I was before. So we want to do better than this. Now, I hate that because sometimes your book will literally go infinitely many solutions. And I hate that because it's just a weakness in the book. But we can do better than that, right? We're math teamers, right? State champions. Okay? So we can do better than this. So we're not going to say infinitely many, even though that's a little bit better than that. We're going to say, hey, the line itself. Or you can just say one of the actual lines, or because the lines are the same, the line itself would be your set of solutions. Because what is a line anyway? A line's just a bunch of what?
Points.
A bunch of points that line up on a slope. A parabola is just a bunch of what? Points. All these curves are just a bunch of points. And the best way to write them is, you can't write them all out there. There are infinitely many points, right? But the best way is just go, hey, all the points that look like this. And that's how you write that formally. So in your book, when it says infinitely many, let me apologize ahead of time. That's not the final authority, right? We're going to say better than that. We're going to say that. Or at the very minimum, just write out the line itself. Okay? All right, so now how do you go about solving these? Well, here's the thing. If I give you two lines that intersect, when you go to solve, you're going to use one of these two methods, and you're going to get an answer, right? You'll get down and you'll have, oh, x equals 5. And then what do you do with that x equals 5? Plug it back in and get the y value that goes with it. But what do you think happens here when they're parallel, or here when they are right on top of each other? I'm not going to get x equals something. Guess what's going to happen? We've actually talked about this.
Like 5 equals 3.
You're going to get, all the variables are going to cancel, and you're going to get something like 5 equals 3. What do you think it means if you get 5 equals 3? That's this. That's null set. But what if you simplify and you get something like 4 equals 4? Oh, that's a true statement. I bet it's the line itself. Okay? So we've actually talked about what that means when you're actually solving. I think you even had a test question on it where all the x's canceled, and you ended up with something like 4 equals negative a, depending on what test, or maybe 5 equals 5. And you got something from it. But let's take a look at this. So, two methods that you've learned. Okay, and by the way, when you look at these two methods, I used to get so frustrated with my teacher because she would give me something like, and I'm going to pick something that works out semi-nice. Sorry. She would give me two equations like this. Miss Wakefield. And if you saw two equations like this, most likely, or what do you think most people would do to solve a system like this? Do you remember?
Elimination.
They'd use the elimination method. And if you remember, the elimination method is we want to either make the x's or the y's opposites so that when we add them together, one of the variables goes away. But she would give me this problem and she'd say, use the substitution method. I'm like, that's just so dumb. Like, why would I do substitution here when it's already set up so nicely? So in your book tonight, if you're doing the problems and it says use the substitution method, completely ignore the book if you would rather use something else. But just make sure that you can do it either way. So I will give you a question on your test that obviously would work great with elimination, or we used to call it the addition-subtraction method. But y'all called it elimination? Is that right? So if it's obviously trending in one direction, then do whatever you think's best for you. Okay? And then I'll give you another one that would obviously be easier to solve using substitution. And we'll use substitution if you want. But if you go, nope, I'm going to do this every time. Well, you probably can on linear functions because they can be written like this, but it might be more work. But you choose. Doesn't matter what the book says to do. Okay, so on this one, if I'm solving it, what would be a good plan? Somebody throw something out there too. So tell me what to do.
Multiply the top by -2 and the bottom by 3.
So multiply the top. I'm going to go with positive 2 and 3. And why would I do that?
3 and subtract.
So the signs will be opposites? Y'all seeing that? And you don't have to do the actual number. I mean, on this case you do. Sometimes it might be easier just to multiply the bottom by something. Or just be creative. But as long as they end, and I'm going to rewrite this, I would encourage you to, unless you like, if you threw down on this test, you made a 90-something or above, and you don't tend to make careless errors, you're probably fine. If you make a lot of careless errors, take the time, guys, to distribute that 2 in, all the way through, distribute that 3 in, all the way through. Remember, all the way through. In fact, it's probably better to put that number on both sides like this, but a lot of you don't, and I understand. And then now I have a new equation, which is still the same 2 lines, right? And now I can linear or elimination method, I can eliminate those, and I end up with 2y equals 11, so y is 11 halves. And then now what do I do?
Solve for x.
I'm going to solve for x by plugging that back in for the y. Now I'm going to plug y in this green equation on the bottom. And it doesn't matter, but I'm going to do that because I see that the 2 in my fraction would cancel with that. It's not going to cancel with that. It's just going to make it a little harder for me maybe. So I'm going to plug it in that bottom equation. So negative 2x plus 4 times the 11 halves equals 1. And now I can cancel to clean it up. and I get negative 2x plus 22 equals 1. Negative 2x equals negative 21, so x equals 21 halves. And the way I write a solution to a pair of lines would be a what? An ordered pair, a point. So 21 halves, comma, 11 halves. And by the way, if you ever see me make a careless error, please tell me quickly so I don't, I'm filming myself, right? So end the pain for the viewers at home. As soon as you see it, don't be afraid to go, is that right? Even if you're wrong and I'm right, who cares, right? I mean, we're all gonna make careless errors from time to time. Are we good? Okay, one other thing. On your test, I tend to avoid ugly fractions. Why? So that you'll have some level of confidence. Now, I don't think those are ugly, but I really do. A lot of times I'll give you whole number answers. Some of you are smart enough and quick enough processors to sit in here and eyeball for answers. Now, what if you did all this right and you wrote down the wrong answer here? What do you think I should do on this?
Minus 1/4.
I'd probably doubt you, right? If you wrote like negative or positive 11 instead. Because the work was great. Oh, a careless error. I'm just going to doubt you, which is minus a fourth, right? Well, what I'm saying is the answer is only worth minus a fourth. So if all I see is the answer, you're going to get counted off if that's all I see. So I'm telling you ahead of time, I'm going to give you probably answers that don't have ugly fractions, maybe a half, -8, simple numbers like that. But I'm doing it so that you have some level of confidence in your math. If you're doing the math and you end up with x equals 27/94, you've made a mistake on my test. I don't do that to people on my test. Okay? At least not in Algebra 1, Algebra 2, and not now. Maybe later on in pre-cal we'll ugly it up a little bit. Are y'all with me? So expect that on your test to see some better looking answers than the book maybe will give you. Okay, elimination. What's the other option?
Substitution.
Substitution. Would you probably do substitution with this?
Nope.
No. So here's more along the lines of what you might see, which would be a good idea with substitution, in my opinion. So, if I threw out there, I like substitution because literally I have already solved for y. And even if I hadn't completely, I'm really close to it, right? And it would be really easy for me to take this y value, the 3x minus 2, which is the y, and just plug it in for y right there. Now, if you look at this and you go, well, I wouldn't have done that. I would have subtracted 3x and done it this way. Fine, I don't care, right? This is just beginning Algebra 2. As long as you can get a solution, I'm good. But I'm going to do it this way on this. So x plus 2 times all of that in parentheses. I would really encourage you to put it in parentheses. Distribute that 2. All right, 7x equals 11. So x is 11/7. And then what do? Plug it back in. And the substitution is great from that perspective because you've already solved for one of the variables, most likely. Not necessarily, but most likely. It's really easy to plug it back in because everything's already over on that right side. Whereas over here, when you plugged it back in, you had to do some math and move it over and divide. Here, it's right there. So you end up with 33/7 minus, and if I find a common denominator, 14/7 ends up giving me 19/7. So my solution is good, 11/7, 19/7. And honestly, that's a little uglier than I'd probably give you on a test. And it's really not that ugly. But I'm telling you, I really do try to give you more whole numbers, integers, that kind of stuff, just so you're kind of like, okay, I feel pretty good about it. All right? Okay. Last thing I want to talk to you about. No, that's not true. 2 more things I want to talk to you about. What would you do? And this question, people at home, people miss all the time because they don't do what I'm asking. They try to be ultra creative. And because they have a habit of not liking fractions and feeling like they just got to get rid of them. Now, if I had $1 for every time somebody went, well, I'm just going to multiply everything through by an XY to get rid of my fractions, I'd have
$1 million.
hundreds at least maybe tens of dollars, but I'd have a lot of dollars, okay? So don't do that. What's my goal? What would you do, substitution or elimination here? Most likely. What does it feel like?
Elimination.
Feels like elimination? Now you could do substitution. It's going to be an ugly substitution. But if it's elimination, aren't you just trying to get rid of an X or get rid of a Y? And to do that, aren't you just making them look the same? Well, not the same, but opposite? So what? Just go with it. Don't let the X and the Y on the bottom freak you out. And believe me, the book does it differently, but this is the safe, easy way to do it. What can I multiply, either the top or the bottom or both by, to make these terms the same? Or opposite? The bottom by what?
2.
Will that make them opposites?
Or negative.
So -2? Will that do it? Okay, check it out. I know it's a little different, but just expand your brain a little bit. The top remains unchanged. And the bottom becomes -6 over x, positive 20 over y, and -6. Now, aren't these terms opposites? Well, cancel them out. Eliminate them. What's 5 over y plus 20 over y? See, you guys know how to do this. 25 over y. And then 1 and -6 is -5. And then what would be the last step, you think? What would you do if you got a y on the bottom?
Multiply the whole equation by y.
You can either multiply the whole equation by y, which would cancel them, and then divide by -5, right? I kind of like the flip both sides. Did y'all know you could do that if it's a fraction equal to a fraction? It's really a long way of doing multiplication and division, but if I have this right here, fraction equal to a fraction, I can flip that and make it y over 25 equals -1 over 5, and then I can multiply by a 25. That works too. But what y'all said initially, if you just multiply through by y, or even just cross multiply. If I cross multiply, I get -5y equals 25, and then I can divide. Any number of ways you could do that, but each and every way you do it, you're going to get y equals -5. So do it, makes you happy, in this case. And then what would you do with that y equals -5?
Plug it into the bottom.
Plug it back in there. Actually, either one, it actually works pretty nicely. But he said the bottom, so we'll go with the bottom. So to find to find x, I'm going to go 3 over x. Now be careful on this. Minus 10 over a -5 equals 3. So what would you do here? So the two negatives make it positive. Then what would you, and then 10 over 5 is 2. So then what?
Subtract 2 from both sides.
Subtract the 2. And then what?
Flip it.
Cross multiply or flip it? In this case, cross multiplying looks nice to me, right? 3 equals x and you'd be done. But if you flip it and multiply by 3, you'll still get x equals 3. So, answer 3 comma -5. How are we feeling? But guys, there's no need to be multiplying through by an xy, because that gives you an xy term here and here, right? If you multiply by xy, 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 and then start canceling, you get this pesky xy term that you can solve, but it makes a mess of things initially. I wouldn't do it. And the book talks about a substitution in here, like replacing technically the 1 over the x with an a and the 1 over the y with a b. It's just not necessary, I don't think. And it makes it a little harder at this point in the game for people. Are y'all tracking with me so far? Okay, let me ask you a question. Anybody play baseball in here? No baseball players? Okay, everybody know how to throw a baseball? Okay, so let's just say I'm a pretty decent baseball player and I've got a, 75-mile-an-hour fastball, and Sam's in the back, right? And I have a baseball and he's got his catcher's mitt on, whatever his equipment, and I take the baseball and I bring it back and I throw it at Sam at 75 miles an hour, he catches it. No problem, right? Now, what if I'm on like a flatbed truck that's screaming down the road at 75 miles an hour, right? And Sam is hanging out on the side of the road with his mitt, right? So now I'm already going 75. And as I see Sam, I'm like, all right, it's on. And I take my baseball, and as I'm flying at him already at 75, I take that and I throw the baseball at 75. How fast is it coming at Sam? The car's already going 75. I throw up 75. It's going to hit Sam's glove at 150, which I personally don't want to catch a 150 mile an hour fastball. Are you following me? Now, it's the same thing on an escalator. Y'all been in airports that are, I don't know, I don't think Birmingham has them. No, Birmingham does not. But like if you go to Chicago or Atlanta, they have the moving sidewalks.
Oh, yeah.
Yeah. So let's just say you're just walking along at like 2 miles an hour and you hop on the moving sidewalk and all of a sudden you're like walking around a little bit faster, right? Why is that? Because your speed, your rate was 2. The escalator might be moving 3. So what's your actual speed to somebody like Sam sitting on the sidelines? 5. It'd be the sum of those. Well, does that make sense? Or how about this? And I still do. Well, it's been a couple of years. But does anybody like when you have an escalator, like in an apartment store, like if you go into Macy's or something and you run up the down escalator?
Yeah.
You ever done that?
Yeah.
I had a cop kick me out of Macy's at the
For doing that?
yeah.
Yeah, well, he's uptight low. It's just good, solid fun. You really can't get hurt. But anyway, well, maybe you can. Anyway, I always liked doing that as a little kid, and I did it with my daughter a couple years ago. Still kind of fun. But the point is, you're going up at, say, like 4 miles an hour, but the thing's coming down at 3 miles an hour, right? So if I'm going up at 4, but the escalator's coming down at 3, what would be the net sum of the speed I'm moving up? +1, right? So isn't that fair to say that a rate sometimes isn't just a plain old rate? Sometimes it's a sum of 2 rates, or maybe even a difference of 2 rates. It might be a sum of 2 rates if I'm throwing a baseball while moving on a flatbed truck, right? It might be a difference of 2 rates if I'm walking this way on a sidewalk that's moving this way. Y'all seeing that? Well, what's going to happen on some of your word problems tonight, and more word problems, you're going to get problems about distance, rate, and time, and they might look like this. All right, so Biff is in a canoe, right? And instead of just floating down the river, he is paddling down the river, okay? And he paddles down the river for a certain amount of time, who knows what, and he makes it from point A to point B. What is his rate? His total rate? Is it just how fast he's paddling?
It's the current with them.
It's the current and that, right? So it'd be those 2 things added together. What if I'm in a plane? My dad is a pilot. He's retired now, but he's a pilot. And he said for instance, I can fly to Denver nonstop, 3 hours and 45 minutes. I can fly back in 3:15. Same distance, right? Why is that? Yeah, there's that jet stream that moves across the country up there. It's like a pocket of air. It's like the East Australian current in Finding Nemo, right? It's a current that you hop into, and even if you're not doing anything, you're going to move along with it, right? So an airplane that's going 450 miles an hour, and that jet stream sometimes moves 80, 100 miles an hour. It's almost like a hurricane force up there. If you get up in that jet stream, and your plane thinks it's doing 420, it might be really doing 520. But if you're flying into it at 420 and it's going this way, you might be only doing 320, right? Because the wind subtracted from your speed. Yes or no? You're following me? So what do you think a tailwind does? Tailwind does what?
Makes you go faster.
Makes you go faster. Pushes on your tail, right? Headwind does what? Slows you down. Tailwind, you're adding to your rate. Headwind is slowing down the rate. Upstream, what's happening? If you paddle upstream,
You're going against the current.
against the current. The current's slowing your rate down. Downstream,
Going with it.
going with it. Well, let me give you an idea. What if I told you, follow with me. What if I said, I got 3 minutes, I think I can squeeze it in. What if I said, you are going to paddle a canoe downstream for 10 miles. Now let's think, distance, rate, and time. But our rate is what? It's a function of 2 things. Maybe plus, maybe minus. So follow me. I paddle my boat for 10 miles downstream. What's downstream going to do? Add my rates together. And some people like to put C in there for current. Maybe. Right? And I don't know how much time it took me. What about this? Then on the way back, same distance, Now I have to paddle upstream. Now what? I'm still paddling at the same rate, right? Or assume I am. Same rate. But I got to go against the current. Okay? And by the way, maybe I did give you times. Maybe I told you, hey, he's going to do that for 3 hours, and he's going to do that for 2 hours and 15 minutes. And 15 minutes would be what, a fourth of an hour? How would you solve this?
With
First of all, what are you going to do with that 2 1/4? We're not going to change it to minutes.
You just change it to improper.
Make it an improper fraction. 9/4? Got 2 minutes. Hang in there. You know what almost everybody does on this problem initially? They distribute it. Now, hold on for a second. If I distribute this, this is what I get. And this is totally fine. If I distribute this, I get. And now you could do what? Elimination? It's going to be kind of a mess though, isn't it? How about this? What if I don't distribute? What if I don't do this? And instead, oh, that's kind of nice. 10/3 equals R plus C. What if I don't distribute that, but multiply by
4 ninths.
4/9? And a lot of times, this even cancels nicely over here. But I get 40/9. Now, how's elimination look out for you? What does it look like?
Good.
Very nice. Are you with me?
Yep.
And I might have to deal with a fraction here, but you know how to do that, right?
Yeah.
I'm telling you, if you see these, set it up as a D equals R plus C, R minus C, or if it's wind, R plus W, R minus W, or R1 plus R2, R1 minus R2. Plug in what you know. Make sure if you do time, you don't change it to minutes. Leave it as an hour. And y'all know how to do something like 12 minutes? 12 minutes is what part of an hour? 12/60ths or 1/5. What about 6 minutes? 6/60ths or 1/10. You can always put it over 60 to find the hour fraction. Hey, try those, do the best you can. And if you have questions, send them to me and I'll try to get them back to you. Or at the very minimum, talk about them tomorrow in class. All right?